We're going to start looking at numbers and how to write them in scientific notation, how to read them in scientific notation, how to rewrite them in standard notation. So standard notation is what we're used to seeing all the time. Standard notation just means written out, expanded, written normally. Here's an example, 7,500. That's standard notation. All right, scientific notation is a way to read very large or very, very small numbers so it's a different way to show very large or very small numbers. There's some rules to it. So I'm going to start with an example. We're going to do 2.7 times 10 to the 5th. Now the rules that go along with it, this number has to be between 1 and 9.9. It can't be 10. This number is always a 10 to some power. So the first number has to be between 1 and 9.9. Second number is always 10 to the some power, and there's always multiplication in the middle. That says multiplication. Anytime I'm multiplying a number by 10 or by 100 or 1,000 or 10,000 or 100,000, what that does is it just moves the decimal point. So this number, 10 to the 5th, is actually 1 with 5 zeros. So what we're doing is we're taking 2.7 times 100,000, and that would be the actual number that we're talking about. It's just easier, especially when you get up into numbers that have maybe 9 zeros, 10 zeros. It's an easier way to look at the number, compare numbers, and it's called scientific notation because you'll use these numbers a lot in science. So let's first look at some examples and decide which ones are and which ones aren't scientific notation. So the first one, 4.5, well, that's a number between 1 and 9.9. So that's okay. 10 squared, it's times a 10 to some power. So this is a yes. Second one, the first number is 42.1. The first number is supposed to be between 1.1, I'm sorry, between 1 and 9.9. So that doesn't work. Third one, 6.02, is between 1 and 9.9. And it's multiplied by 10 to some power. So yes. Okay, now we're going to look at how to write numbers either from scientific notation to standard notation or standard notation to scientific notation. So in the first example, I see a 4.6 times 10 to the 6. Obviously that is written in scientific notation. So we're going to write it in standard form. So the 6 on the 10, the exponent 6, tells me that I need to, whenever I multiply by a 10 to something, it just basically moves the decimal point. So the 6 tells me how many times to move the decimal point. So right now the decimal point's between the 4 and the 6 and 4.6. If I move it 6 places, there's 1. That 6 takes up one of the places. 2, 3, 4, 5, 6. and it's going to end up down here at the end of the number. I need to fill this in with zeros. Now, it's not necessary to make loop loops all the time. If you think about the fact that you're moving it 6 places, that 6 in the 4.6 is going to take up 1 place. You'll have to fill in the rest with zeros. And I don't want to see loop-de-loops on answers. So we ended up with a 4, a 6, and 5 zeros. And put commas in answers. So this ends up being 4,600,000. We moved the decimal 6 places to the right. On the next example, we have a 5.7 times 10 to the negative 4. When we did negative exponents last time in class, they all were fraction answers, meaning very small numbers. Scientific notation, same thing, except we're not going to write it as a fraction, we're going to write them as decimals. So the negative 4 on the 10 tells us to move the decimal point 4 places, but we want to move it in a direction that's going to make 5.7 smaller. So if I go backwards, there's 1 place plus 3 more places. Makes 4 places total. So my answer is 0.00057. And you can choose to write the 0 in front of the decimal point, but it's not always necessary. So we moved the decimal places 4 places to the left. So positive exponent means bigger number, negative exponent means smaller number. Let's go the other way. So now we're going to take this huge number that's in standard notation and we're going to write it in scientific notation. So the decimal point right now is at the end of the number because we don't see it. So it's something 0.0. So the decimal point's at the very end. I just put it there in purple. I need to move it back until I have a number that's between 1 and 9.9. So if I stop there, that's 67. It's not small enough. It's not between 1 and 9.9. So I need to move it 1 more place back. If I stop right there, that would be 6.7, which is perfect. So I'm not making loop-de-loops on this one. I'm going to count zeros. So I move 3, 6, 9, plus the 7 makes 10 places. So I need to move that decimal point 10 places back. So we know we're going to have 6.7. I'm moving the decimal point 10 places. So I'm multiplying times 10 to the 10th for the 10 places. And that was a very big number, so I'm going to keep my exponent positive. So that is 67 billion written as a scientific notation number. And let's do one more example together. Now obviously we're seeing a very small number. So first of all, decide where you want to move the decimal point to. We need a number between 1 and 9.9. I'm feeling 5.6. So if I look and count my zeros, I have to move across 8 zeros, plus I have to move across the 5, which makes 9. So I know my exponent on my 10 is going to be a 9. And since we started with a very, very, very small number, make it a negative 9. So small number, negative exponent. Not a negative number, just a negative exponent. There are some examples on the back of your paper that you should try, and you should have them checked and initialed by the teacher, and you may start on your homework.